Hi, my name is Stuart Lynch, and in this video, I'd like to show you how you can use your free GitHub account and GitHub Pages to provide a way for you to present dynamic alerts in your apps should you have the need to urgently contact your users without having to submit an update to the App Store. If this is something you want to learn, then keep watching. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. There may be times that you have an urgent need to alert users of your apps, and you need to do this without having to wait for an App Store update. Perhaps a recent OS update is causing an issue with some functionality in your app, and you need a little time to work on it. Or you're getting bad reviews or support emails or getting out of control. Wouldn't it be nice if you could somehow get the word out to the users that you are working on it and that a fix will be coming soon? Or maybe you need to provide them with a link to some site that will show them a temporary workaround. Well, that's what this video is all about. I need to find a way to present an in-app alert to all of my users at any time without pushing out a new version. So I'm going to accomplish this by storing a small JSON object in a specific location on one of my GitHub repositories so that I can update it at will and then have my app fetch and decode it. My app will perform a check to see if it has already seen that information, and if not, present an alert using the information decoded from the fetched JSON object. The first thing I want to do is create a sample application to test out my solution. Each application will have a unique bundle ID, and we're going to use that to make sure that we're grabbing the correct JSON object from the array that we'll be decoding. I want to use that same JSON payload for all of my applications, with each object in the array being a potential message for one of my apps. I'll be able to know which one it is by its app's bundle ID. So you can call the app anything you want. I'm going to call mine App Alert Example. Once the app has been created, make note or copy the bundle identifier. In my case, it's com.createexall.appalertexample. Well, GitHub Pages is a static site hosting service that takes HTML, CSS, and JavaScript files straight from a repository on GitHub and publishes a website. GitHub Pages is available in public repositories with GitHub Free and in public and private repositories with GitHub Pro. So the only requirement is that you have a GitHub account, and since it's now free for unlimited public and private repositories, there's no financial barrier for you to get started. Just that your JSON code, if you have a free account, will be public. And you can find out more about GitHub Pages here at this link. So let me step you through the process of creating a repository that will act as our GitHub Pages source. In this example, I'm logged into my demo GitHub account. Yes, I have a real one, but since it's a free account here, I've created this demo account for demonstration purposes. Since I don't pay for this account, I'm going to have to make my repository a public one if I want to make my Pages JSON available. This really isn't a problem though. Once you have your account and you're logged in, create a new repository and call it App Alert. You can create a new file from the resulting page once the repository has been created by clicking on the Get Started by Creating a New File link. It's in this file that we want to create our JSON object that will allow us to decode in our apps, so call the file messages.json. For the body of the file, we can have an array of JSON objects that will represent the information that we want to use to present an alert in our application when necessary. Start with an empty array, and within that array, we can create a JSON object for every one of the apps that we want to use to deploy the solution to. So for example, I'm going to create a JSON object with 5 key value pairs. The first will be an ID, and it's going to be an int representing the message number. So I'll set the value to 1, indicating that this will be the first message ever presented in the app. Next, the key will be for bundle ID, And the value will be the value for that app bundle ID, which I copied. So I'll paste it in as a string. Next, a title key. And that's going to represent the title used on an alert. So for the value, we can provide an appropriate string. I'll follow this with a text key to represent the message text in the alert. And the value, again, will be a string, and I'll just provide an appropriate string for testing here. For the final key, I'm going to use confirm label and provide a string that we'll want to use for the dismiss or confirmation button label on the alert. Make sure you commit and save this update. And you can use the default message provided for the commit. When you do that, you'll be presented with this error alert. Don't worry about that. Just go to the default branch, which in our case is main. Next, you'll need to set up pages in your GitHub repository so that you can provide your JSON object upon a fetch request from your app. So click on the Settings tab at the top, click on Pages on the sidebar, and then choose the main branch, and click on Save. It'll take a short time to deploy, maybe up to about 30 seconds, but if you keep refreshing the browser, you'll see it in the notification on this page, providing you with a link to the root of your new Pages website. Well, this is the link to the root folder, and since we called the file messages.json, the link to that file will be the root/messages.json. So if I copy that URL into the browser's search navigation field and make sure I add the messages.json and press enter, we'll see that the JSON gets returned. This is exactly what I need to fetch from our application and then decode it into an array of messages and find the one that will correspond to my application's bundle ID if I have many objects in the array. Now it's up to you to create a generic alert service that you can use in all of your apps, including the demo one. So to make this a drop-in reusable service or potentially create a Swift package for this, you can create a class using the observation framework introduced in iOS 17 to monitor changes. So in your project, create a new Swift file and call it alert service. Within that file, create a class using that same name, but apply the @observable macro to it. Within the class, create a struct that will model your JSON object. So we'll call this struct message and have it conform to the codable protocol. The struct will need the 5 properties where the property names match the keys in the JSON object created in our GitHub Pages' messages.json array. And all values will be strings except for the ID property, which is an int, and we'll only display this message when we receive some valid JSON in the fetch, so you can provide some default values for each, as they'll be updated when the JSON is decoded. Next, we'll create some class properties here. The first one will be JSON URL, and that'll be a string, and we'll pass in the string for the URL when the class is initialized, and that URL will point to that messages.json file. The second property will be a convenience property called bundle identifier, and it'll be a string representing the application's bundle identifier. So I can initialize this using bundle.main.bundleIdentifier, and you'll need to force unwrap it. Now, if your app doesn't have a bundle ID, you're really in trouble. Next, you'll need an instance of the message struct that will be updated with values from the decoded JSON. Well, we'll only be presenting an alert if it's necessary, and in that case, our view will need to be monitoring some Boolean properties so that if it changes to true, we can present an alert. So create a Boolean property called showMessage and initialize it as false. Well, every time the app runs, we want to be able to fetch and decode the JSON, find the object corresponding to the application's bundle ID, and then compare the ID to one that you will have persisted in your application somewhere. Now, if that ID is greater than the one stored, then we want to present the message as an alert and update the ID so that it doesn't present again next time the application launches. So how do we persist a value in our application? Well, app storage is a good place to do this, but since I'm not in a SwiftUI view and I'm using this new observation framework, I can't use app storage here. So I'm going to create instead a property called lastMessageID as an int and revert to user defaults for getting and setting this value. For the get, I can use the userdefaults.standard.integer for key, and I'll specify a string lastMessageID. The first time it seeks this, it won't find it, so it'll default to 0 as the integer. This means your JSON object that is fetched is greater than 0, so it should display an alert using the message information in that JSON object. When that object gets displayed, we want to update. So in the set, we can use the userDefaults standard set value and provide a new value for that same key that was used in the getter. With all of those properties created now, the JSON URL string has not been initialized. So we'll need to create an initializer for this. Next, we can create an async function that will fetch the JSON, decode it, filter it to the one matching the app's bundle ID, and then update the observed message object. So we'll call the function fetchMessage, and then we'll use the modern concurrency methods to specify that it's asynchronous. Within the body, I'll create a doCatch block. In the do, we'll fetch the data from the URL by trying to await the result of calling the url.session.data from the data formed by the static URL. And this URL will have to be unwrapped. Next, the message must be the result of trying to use a JSON decoder to decode from the array of message type, so self, from that data that was fetched. Now this will provide an array, so we'll need to find the first one where the iterator's bundle ID is equal to the bundle identifier. This, however, will be an optional value. So I'm going to use an if-let to unwrap it into a single, non-optional message. If it's able to do that, then we'll update the self.message to the message that we've decoded and unwrapped. In the catch block, then, if something has failed, then the JSON couldn't have been decoded, but as far as the end user is concerned, nothing will happen in that case. So we'll just make sure that we have a proper JSON array and a message struct that can successfully decode from the array. So I'll just print a statement could not decode to the console. So to present an alert, we're going to have to toggle some state property in one of the app's views, preferably the first view presented. So in the case of our application, this is going to be our content view. So we'll call the function showAlert if necessary, and within this function we'll be calling the fetchMessage function, so this function needs to be asynchronous as well. In the body, I'll await the call to the fetchMessage, and if successful, the message object will either have been updated or it would have printed out the error to the console and the user is none the wiser. If I'm successfully decoding it, though, we'll check to see if the message ID is greater than that stored last message in our user defaults. If it is, I'll toggle the show message. And then I'll set the last message ID in user defaults to this message ID that was fetched, so that it won't get displayed again. That's it. Now, all you have to do is initialize an instance of the alert service in Content View and pass in the URL to this JSON payload. And then when the view appears, we can create a task and await the result of calling the alert service's show alert if necessary function. If this results in the observed show message property being toggled, we can present an alert using the values obtained from the updated message object. Before I do that though, let me just move this alert service into the app folder. In the content view for our application then, we can create a new state property that'll initialize the alert service. So we'll call it the alert service, and then we'll pass in the URL to our messages.json. When the view appears, we'll need to use a task instead of onAppear, as the call to our show alert if necessary function needs to be asynchronous. So within the body, we can await the result of the alert service's show alert if necessary function. And this will either toggle the state property or not, depending on whether or not the condition has been met, i.e. the stored fetch message ID has to be greater than the stored last message ID. And then we can attach to one of our views an alert that will be presented based on the status of that show message from the alert service. So the title key will be the alert service's message.title property, and is bound to that alert service's show message as a binding. The first closure allows us to create action buttons. So for the first one, we'll create a button with the label provided by the alert service's message.confirm label. But I'll leave the action empty. And this will simply provide a way to dismiss the alert. For the message closure, it'll be a text view displaying the alert service's message.text property. So let me run this on our simulator right now. Now, since our last message ID will be 0 and the fetched ID from our JSON, messages.json, is a 1, it should trigger the presentation of the alert, which it does. And the last message ID then will get updated to that new value. So if I run the application again, the alert's not presented. Perfect. Just checking to see if an alert has been displayed or not may not be granular enough for your needs, or perhaps you'd like to provide a way for users to get more information about the issue. It could quite possibly be the case that the problem only affects a particular app version or OS version that the user is currently running on their device. So in this section, we'll account for both of these cases. In the app services, create a new static property called app version. And to obtain this, you can access the bundle.main.info dictionary, providing the key cfbundle short version string, and cast it as a string. And that info dictionary must also be unwrapped. And then create a second static property called OS version. And this can be derived from the UIDevice.current.system version. But since this is accessing the UIKit framework, you'll need to import UIKit. Now, if you want to see the output of these two properties when the app launches, you can add two print statements to an onAppear block at the app starting point. So we'll do that. We'll create the onAppear and then print both of these app service static properties. And then when I run the app, we see that those two values, their strings, get printed to the console. Next, you'll need to update the message struct so that it can decode the JSON if any of those two properties have corresponding values from the key value pairs that we might provide. Since we may not care about these two properties, you can make them optional But you might also want to check for more than one app version or OS version, so you'll need to make these two properties optional arrays of strings representing the possible versions to check against. So I'd recommend that you use plural for both to signify that your properties are arrays. The next property will be used for the alert presentation. If it exists, we want to provide a string for a label and another one for a URL that we can form a URL from, and then add another action to our alert that will be a link button with the label being provided and the destination, the provided URL. Since this is two properties and they are associated with each other, unlike the first two, you can create a struct called link to represent these two properties. And since it will have to be decoded, it must conform to the codable protocol. And then within the struct, we can create two properties, one for title and one for URL. Both are strings. And again, since you may not want to include this link every time you present an alert, you can make it optional as an additional property for your message struct. This will mean that the existing message JSON is still valid for the current message instance already tested. So you now have potentially 3 more properties being decoded from the fetch JSON. If the key value pairs are found, these optional values will be part of your decoded message and filtered message. 2 of those properties will be used as checks along with the ID to determine if indeed an alert needs to be presented. And the link property will determine if the alert will have an additional link button. Well, now that there are 2 more properties to check and compare to see if an alert must be presented, the code on the show alert if necessary function has to change to accommodate this. You can leave the await for fetch message function call, but instead of using an if statement, we're going to replace this with a guard statement. Guard checking that the message ID is greater than the last message ID requires that you provide an else statement. And the else clause is run when the guard check fails, so you can simply return and do nothing. Follow this with another check that will use an if-let to check for and unwrap the messages.os version if it is in fact there, and then decode it, meaning that the JSON provided an OS version's key. So if this is true, you can create another guard check to see if the found array contains the static self.os version. If it does not, in the else clause, you can return from the function and go no further. Or you can do a similar if-let check to unwrap and check if the decoded app versions property contains the self app version, else return. And if the version has not returned yet, then only now can you toggle the show message property and set the last message ID to the message.id. Well, you still need to handle the case in the alert where a link object was decoded. So in Content View, you can check to see if it was made available to you when you fetched and decoded the JSON. So after the button, use an if-let to unwrap it, and then create a link button using the link.title as the label, and then the link.url to form a URL with that string for the destination URL. And it'll have to be unwrapped, so you better make sure that it's correct. Well, there's also something that I don't particularly like about this implementation so far. If you look at the code for this alert, you'll notice that it'll be the same for every app. It's generic. So why not bring that code into your alert service as a view modifier? So cut the entire alert code out and return to the alert services file and class. You'll need to import SwiftUI as you'll have to create a view modifier. So since this also includes UIKit, you can change the import from UIKit to SwiftUI. Inside the alert service class, create a new view modifier called alert modifier that'll conform to view modifier. And a view modifier has one requirement, a body function that has content as a parameter, and it'll return some view. And then you can use that content and then apply that alert to it. So you can simply paste in the alert that you copied from content view as the modifier for content. Well, this will complain because there's no alert service, so we'll need to pass that in when we call the modifier. So create a new property called alert service that is of type alert service, and it will have to be a bindable object. Then one final thing to make this even better is outside of this class, create an extension for view. And then within the extension, create a function called message alert that has a single parameter, that's an alert service. And in the body, apply the modifier function, passing in the alert service alert modifier, providing an alert service as the argument. And then finally, returning to content view where we remove the alert, you can simply apply this new modifier, which is the message alert, passing in the alert service. With those changes made, you can now provide a new JSON payload to your users, providing any of those optional properties as key value pairs. And since your message struct specifies that all three are optional, you can leave 1, 2, or all 3 out of the mix. So back in your GitHub repo then, where your messages.json document is, you can adjust your JSON to accommodate the change. So of course you'll need to increment the ID because that is always checked. And then you can change the title and the text to something more appropriate to what you're wanting to get your point across. In this example, I'm going to check for both the app version and the OS version. So I'm going to add 2 key value pairs. And make sure you add a comma after that confirm label key value pair. For the first, create a key OS versions. And for the value, create an array of strings representing each of the different OS versions that the issue might apply to. For example, at the time this document or video was created, the current iOS version is 17.0.1. That's a string. But I also run a beta version, which is 17.2. So I'm going to have an array of these 2 strings. For the second, create a key with the string app versions, and this too will be an array of your app versions that the issue might apply to. So for example, you can check what the current version of your app is by either running the app and seeing what gets printed to the console, or you can check the General tab for your app target and find it in the version field. So we'll need to create a single string element in the array, but in the future, the issue might also apply to previous versions of your app, so you'd have to include them as well. So the key strings correspond to the property names for your 2 optional version properties in the message struct. And that means because they're optional, you can omit one or more of these properties in your JSON. However, if you include one or both of them, you must provide an array of strings or an empty array. Now the link for our presentation in the alert will be an optional button on the alert that will allow the user to navigate to an external website by tapping on that link. So that link object will have 2 key value pairs. So this is going to require another JSON object. Again, make sure you add a comma after that last key value pair. So link is the key and the value is an object. And inside that new JSON object, you can create 2 key value pairs. Both are strings, and the keys represent the names of the properties that we put in our link struct. So title, and the value will be a string to be used on the links button. So more information. And then the second will be the key URL, and that's the value that the string will be to point us to a URL of the destination. So I'm just going to use my own personal website. And then make sure you commit and save the changes. Now it'll take up to 30 seconds for GitHub to clear its cache and update the site. You can keep entering that URL that is on our pages and adding the messages.json as the last path, and keep refreshing the page, waiting for it to have been updated. Once it's been updated, you can return to your app and run it. This time, when the app is run, 3 checks have to be made. In the first case, because our ID has been updated to 2, that first check is guaranteed. For the OS versions, it's checking for 2 different OS versions, and because ours is 17.0.1, it passes that test. And the app version has to be 1.0, which ours is, so that test is passed as well. And the alert is presented along with that link in it. And we can tap on that link button, and it'll take us directly to the specified website. If you run the app once more, you'll see that the alert no longer gets presented. It's exactly what we want. Now, it may be the case as you're testing your app and updating the JSON on your GitHub page that when you return and run your app, the alert's not presented, even though the JSON payload has been updated. Why would this be the case? Well, it turns out that your app is caching the HTML content. Now, eventually the cache gets purged. If you wait long enough, it will. Well, this is not really going to be an issue for your users because by the time it gets out there, it'll have already been cleared for your users. But if you're impatient during testing and would like to clear that cache immediately for testing purposes, you can do that. You just need to know where to look for that cache. And as another thought, perhaps you just want to update the stored last message ID. Where is that information persisted? Well, let's add 2 more static properties to our alert service. I'm going to name the first one cache's location, and it'll use the static URL property cache's directory. And then the second static property I'm going to call user defaults location. And for that, it can be found in the URL static libraries directory by appending the path preferences. So back now where the app launches in that onAppear block, I can add 2 more print statements to print out those 2 static properties and then apply the path for easy copying and locating in Finder, as you'll see shortly. When I run the app, you'll find that these 2 URLs are printed to the console. Now, if you're not getting an alert and you expect one, it could be that the cache hasn't been purged. So you can right-click on the cache's path in the console and choose Open from the Services menu to run the service and open the Finder window showing the cache. To clear the cache, you can simply just delete it and run again. Now, if you want to test the app out again, you can either go back and update the JSON object by providing a higher ID value or change the app's version number, or you can change the value stored in user defaults so that it's less than the value in your message ID. If you don't update the JSON but still want to verify that all is well, you can either delete the current user defaults and run again, or delete the app on the simulator and run again. However, you may have other values persisted in user defaults unrelated to this alert, so deleting user defaults may not be a great idea. What you can do is update that single value by setting it back to some lower value than the ID in the message JSON for this application. Well, it turns out that this is just a file in the preferences folder in your app. And you can use that link to go there in the same way that you open the cache's location. But it's in that same location as our cache's directory was, or at least at the same level. So you can find it here, and if you double click on this, it'll open in Xcode. And you'll find that the ID has a value which is the same as the ID in that JSON object. So if I change this value to any number less than that and save it, and if I run the app once more, the alert pops up. Perfect. Now, if a user hasn't used your app in a long time, or if you have new installations, it's quite possible that when they launch your app, they'll be presented with an alert that may no longer be valid. Others who have been faithfully using your app regularly will have fetched that JSON and, if applicable, will have had the alert presented, and their stored last message ID would have been updated. However, those other users will not, so they might still be presented with an alert. So it's important then, once your issue has been resolved, that you cancel the alert. Well, this cancellation can be done in a couple of different ways. You could just reset the value of the ID value in your JSON back to 0, and it'll never be presented again to anybody. However, the danger here is that you might forget what that last ID value was, so that when you are ready to present a new alert, you might forget what that value was and fail to use a higher integer value for the ID. So a better solution would be to keep the last ID the same, but either add a new value for the OS versions or app versions key that will never be true. So for example, you could choose an OS versions and then just provide an array with a single element that is the string 0. Same thing for app versions. Either one will work. And then, when you're ready to update the alert for this application, you can increment the ID number and then either remove any unnecessary OS versions or app version key value pairs, or replace the array with values that actually apply. Remember, you can use the same messages.json file for all of your apps, as it's an array where each object in the array represents a different application. So I hope you found this tutorial helpful and that you can see uses for this technique in your own projects. I'm sure you can get creative with the JSON payload so that you can provide much more information, and instead of presenting an alert, present a modal sheet instead, for example. It's all up to your own imagination here. It's extremely powerful. So if you enjoyed this video, please give it a thumbs up and leave me a comment. And be sure to subscribe to my channel and enable notifications so that you'll know when new videos are published. Thanks so much for watching.